5.3 Factoring quadratic expressions. What we're going to do is we're going to look at factoring. You did this once back in Algebra 1. I have 3a squared minus 12a. Factoring means you try to find out what they have in common. Variable expressions. First thing we do is look at the numbers. I have a 3 and I have a 12. Do they have anything in common? How many times does 4 go into 3? They have 3 in common. How many times does 3 go into 3? Once. How many times does 3 go into 12? 4. Now we look at the variables. I have an a squared and an a. What do they have in common? An a. So I'm going to pull out or factor out an a. If I pull an a out of an a squared, what am I left with? Just one a. If I pull an a out of an a, what am I left with? Just one. It just pulled out. Factored, I have 3a times the quantity of a minus 4. That is its factored form. Just to show you, I can multiply through, distribute. What's 3a times a? 3a squared. What's 3a times negative 4? Negative 12a. It got me back to the normal. What I'm talking about when I'm saying zeros. If I change this expression into an equation and make it equal to 0, we want to find out what values for a will give me 0. So in other words, what I'm going to do, I'm going to take this piece here, equals 0. 3a equals 0. What do I do? Divide by 3, and a is 0. If I take this piece right here and set it equal to 0, a minus 4 equals 0. Not minus 4, add 4. So a is 4. This is my zeros, just to show you. If I substitute in this 0, 3 times 0 times a, or 0 minus 4. What's 3 times 0? 0 times anything is, so that's true. Just to show you on the other side, 3 times 4, and then 4 minus 4. What's 4 minus 4? 0. Anything times 0 is 0. Let's factor this one. Actually, this one's a little bit different. You should have done a problem like this in Algebra 1. Should have. What do you notice about both of these? They have the same. It's sort of like I have 3xa minus 5a. What do they both have in common? The big A, which is my parentheses. So I pull out the parentheses. If I take the parentheses out of this one, what am I left with? 3x. If I take the parentheses out of this one, I'm left with minus 5. This is factored by grouping. Now, if I want to find the zeros, if this is 0, this times this is going to be 0. If this is 0, this times this will get me 0. I take each one individually, and I set them equal to 0. You only do this if I'm asking for the zeros. If it just says factor, you leave it up top. So on this first one, what do I have to do? Subtract 5 over. 4x equals negative 5. My next step is divide by 4. So x is negative 5 fourths. Over on this side, first, I need to add 5. So 3x equals 5. Divide by 3, x is 5 thirds. I can just show you on the calculator real quick. If I take 4 times negative 5 fourths plus 5, I get 0. So this is 0. 0 times anything is 0. On the other side, 3 times negative 5 thirds minus 5. I made a mistake. It wasn't negative, it was positive. I get 0. Since they're both 0, they're fine. Any questions on this piece or this piece, finding the zeros? I want you to factor this one and see if you can find the zeros. All right, looking at my factoring, what do both of these have in common? A 5. How about the variable? They both have an x. If I pull a 5x out of a 5x squared, I'm left with x. If I pull a 5x out of a 15x, I'm left with 3. To find the zeros, you don't always have to do this unless I ask for them. I don't want you doing more work than you have to. I set this here, 5x equal to 0. Divide by 5, x is 0. Over here I have x plus 3 equals 0. Subtract 3, x is negative 3. You're going to get to the point where you don't even have to do this piece over here. You just know, okay, 5x equals 0, x is 0. X plus 3 equals 0, x has to be negative 3. Let's try this one. First thing you notice about this problem, these are the same, right? When they are identical, I can pull out that identical piece. 2x minus 1. That's that parenthesis. If I get rid of it here, what am I left with? 4. If I get rid of it here, so plus x. That's what it looks like factored. If I want to find the zeros, I set this equal to 0. What do I get for this problem to make it 0? I want to see if you can visualize it. What do I have to do first? If I think about it in my head, I have 2x minus 1 equals 0. What do I have to do first? Add 1. Then what do I need to do? Divide by 2. X is 1/2. If I visualize this one in my head, 4 plus x equals 0. What do I have to do? Subtract 4, so x is negative 4. All you need to do is try to visualize it in your head. This equal to 0, okay, I have to add 1, divide by 2. You don't need to show me the work. How about this one now? I gave you two of the easiest types of factoring. These coming up, you have to do a little bit of thinking. I have x squared plus 7x plus 10. All right, these two have x's, but this one doesn't. They don't have any number in common. The only time you can pull something out is if all the terms have something in common. All the terms could be divided by 5x. All the terms had this 2x minus 1. This one doesn't have that. But we need to get it factored. So we do our parentheses. I look at my first term. How can I get an x squared? X times x. Is there any other way to get x squared? No, so it has to be an x here and an x here. What are the factors of 10? Okay, this is what a lot of people do. You just randomly throw out the numbers, right? And what happens is if I gave you a large number like 84, you're just going to start throwing out numbers, right? What's going to most likely happen? Most likely you're going to miss one. So I like to go in order. 1 times 10. 2 times 5. Can 3 go into it? Can 4 go into it? I'm back to 5 and I already have 5. I've got them all. So this is the way I can multiply to get a 10. Look at this right here. What sign is that? Positive. How can I multiply and get a positive? 2 negatives or 2 positives. This middle term, if we're thinking of this of undistributing, unfoiling, what's this sign? Positive. Can I ever put 2 negatives together and get a positive? -5 and -2 is -7. 2 negatives put together adding are always going to give me negatives. So I need 2 signs that are the same, and they both have to be positive. This sign right here tells me if they're the same or if they're different. This here told me it was positive. So what 2 numbers multiply to get me 10, but add together to get me 7? 5 and 2. And here it doesn't matter what order I put them in. If I factor this, it is x plus 2, x plus 5. Let me show you, I'm going to distribute it. What's x times x? X squared. What's x times 5x? Or sorry, x times 5. 5x. 2 times x. 2x. And 2 times 5. 10. I got my 7x here. If you remember when I showed you the shortcut way to do it, you take x times x is x squared. 2 plus 5 is 7, so it's going to be 7x. 2 times 5 is 10, so that's my 10. If I want to find my zeros, what makes this one a 0? -2. What makes this one a negative? Or makes it a 0? -5. Those are my zeros. I look at the x squared. How can I multiply to get an x squared? X and x. That is the only way. The next thing I look at is this sign right here. That is positive. Since they are positive, the signs have to be the same. So they both have to be positive. Now, how can I multiply to get a 6? 1 times 6, 2 times 3, and then 3 times 2, I'm back. How can I add together and get a 5? 3 and 2. And it doesn't matter if I put 3 and 2 or 2 and 3 here. If I go through and FOIL this, x times x, x squared. X times 3 is 3x, 2 times x is 2x, 3x and 2x is 5x. 2 times 3 is 6. What are my zeros? -2 and -3. You understand what we did here? Here's this one. X squared minus 7x minus 30. How can I get an x squared? X times x. Most of them you're going to be doing are just x squared right now. Now, for the 30, actually, a negative. Negative, how can I multiply to get a negative? Negative and a positive. So one has to be positive, one of them has to be negative. Now, don't just randomly shout out the factors. You got to start getting to the habit of putting them in order. It helps you out. What's the lowest factor? 1 and 30. 2 and 15. 3 and 10. 4 dozen, and 5 and 6. Now, they need to multiply to get me 30. But now I have a 7. What would you do if the signs were different? What if I had a -3 and a +5? You subtract. So I need to subtract and get a 7. How do I subtract from those numbers and get a 7? The 10 and 3. Now, it matters where I put them. This sign here is negative. So the bigger number has to be negative. The bigger number always overpowers the smaller one. Which one's the bigger number? The 10. So the 10 has to be negative. The 3 has to be positive. If I put them in the wrong spot, if I put plus 10 minus 3, x squared. 10 times -3, I get the -30. But x times 3, or -3 is -3x. 10 times x is 10x. 10 minus 3 is 7x. What's wrong? It's a plus and it should be a minus. You need to be careful of which one goes where. What are my zeros? -3, positive 10. Here, I have x squared plus 10x minus 24. I want to see if you can factor this one. There's a reason why I have this one up here. The only way I can get an x squared is an x and an x. What does this negative tell me? One has to be positive, one has to be negative. What do you do when one number is positive, one number is negative? Do you add them together or subtract them? Subtract. I need all the factors of 24. 1 and 24. 2 and 12. 3 and 8. 4 and 6. 5 doesn't. We're back to 6. I need to subtract numbers to get a 10. 12 and 2. Yes, 4 and 6 do add to get me 10. But since the signs are different, you have to subtract them. So I got to figure out which one is a positive, which one's the negative. The bigger number takes that sign. So 12 takes the positive, 2 takes the negative. X plus 12, x minus 2, which means I have zeros at negative 12 and positive 2. I have to subtract the two numbers. This is what you might have done. You put a 6 here and a 4 there. All right. Put the 4 there, the 6 here. X times x, x squared. X times negative 6, negative 6x. 4 times x, 4x. 4 times negative 6, negative 24. The end pieces are fine. So this middle piece, what do I have? Negative 2. That's where you have to be careful. Now I have this problem. 6x squared plus 11x plus 3. I don't want you to start on this one. I just want you to write it down first. What do you notice? There's a 6 out front. This is when the problems get a little bit more difficult. When there's a number out front, the leading coefficient, you have a number. How can I get a 6x squared? 3x and a 2x, or a 1x and a 6x. What does this tell me here? They're both the same, and they both have to be positive. How can I get a 3? 1 times 3. Now, here's the tricky part. I got to do some sort of combination to get an 11x in the middle. So I could take 1 times 3x and I get 3x. 3 times 2x and I get 6x. Will I get an 11x? No. So that didn't work. But if I do 1 times, well, let's try 1 times x and I get 1x. 3 times 6x gets me 18x. That's not 11. I could try 3 times 3x is 9x. 1 times 2x is 2x. What do I get in the middle? 11. So I know it has to be this one and this one. 3x and 2x. Now, what did I multiply that 3x by? Did I multiply by the 1 or the 3? 3. So I have to put the 3 over here. And the 1 will go here. These ones are more like a puzzle that you have to piece together properly. Do you see how I picked these numbers? Because how did I get this 9x? 3x times 3. 3x times 3. The number you multiplied has to go over here. Just to show you if I FOIL this. Yes, I do get the 3x times 3 is 9x. 3x times 2x is 6x squared. I did it out of order. 1 times 2x is 2x. And 1 times 3 is 3. 6x squared. 9x and 2x is 11x. And I'm left with 3. So I got the same answer. What are my zeros? What are my zeros? negative 1/3, because I subtract 1 divided by 3, negative 3/2. Subtract the 3 over, divide by 2. How about this one? I have 3x squared plus 11x minus 20. Only way I can get a 3x squared is a 3x and a 1x, right? So I know that has to be 3x. I know that has to be an x. That's the only way I can get that one. What does this tell me? One has to be positive, one has to be negative, but I don't know which one. This just tells me I have to end up with a positive 11. How can I get a 20? 1 and 20, 2 and 10, 4 and 5. So I need some sort of combination where I'm going to subtract and get a positive 11. And I got to use these numbers over here. So like 3x times 1 is 3x. X times 20 is 20x. Yeah, 23x is too big. That 20 is probably going to be too big in general. 2 times 3 is 6. 1 times I got 16. 10 times 3 is 30. That's too big. Now I know it has to be a 4 and a 5. But it's which one? I forgot to subtract on these ones. What's 3 times 4? 12. What's 5 times 1? 5. Can I subtract and get an 11? Okay, flip it around. What's 5 times 3x? 15x. What's 4 times 1? 4x. Can I subtract and get 11? So I took the 3x and I multiplied by what? 5. And I took this x and I multiplied it by 4. Now, did we have a positive 15 or a negative 15? We need a positive 15, because positive 15 minus 4 will give me 11. Plus, minus. My zeros are 4/3 and negative 5.